So this is our last question. So the question is, what is the magnitude of the electrostatic force of attraction between an alpha particle and an electron 10 minus 13 meter apart? So let's read it again. What is the magnitude of the electrostatic force? So they are asking us to calculate the electrostatic force of attraction between what? An alpha particle and an electron 10 minus 13 meter apart. So you notice that they're talking about um force of either attraction, okay, they specified of attraction between an alpha particle and an electron. So we're talking about charges and talk about the force between them. So when you talk about charges and the force between them, what comes into mind if you're studying physics is Coulomb's law. And Coulomb's law is F, which is force, is equal to K Q1 Q2 over R square, where K is the constant of proportionality, Q1 is the charge, Q2 charge, and R2 is R square is the distance between them with the power of 2. So now we're being asked to get the electrostatic force, that is F, the force of attraction. It was specified that it's one of us attraction because can also have a force of repulsion. So between an alpha particle and an electron. So they did not give us the value of the charge the alpha particle carries, neither the value of the charge the electron carried. This is some fundamental things you have to know. Firstly, an alpha particle is made up of a proton and neutron. So it has two protons, that is plus two protons. That is for alpha particle. And a proton has what? The same as charge. No, not plus two, just two proton. Proton has a charge of what? Plus 1.6 times 10 raised power minus 19 coulomb. So one alpha particle is equal to what? 2 times 1.6 times 10 to the minus 19 coulomb. And electron is what? Minus 1.6 times 10 to the minus 19 coulomb. So you need to know this offhand for you to solve such kind of question. And also the constant of proportionality for Coulomb's law, K is 9 times 10 raised power of 9 Newton meter square per coulomb square. Then our distance is given, R is 10 raised power of minus 13 meter. So let's plug all of this into our equation to get our answer. So we get F equal to 9 times 10 is 12. 9 times our Q1 is what? Q1, let's take this as our particle as Q1. Let's take this to be Q2. So Q1 is 2 times 1, take note of the positive sign, plus 1.6 times 10 to the 12 minus 19 times minus 1.6 times 10 to the minus 19 over distance, that is 10 minus 13 since it's square, so we multiply it again times 10 minus 13. So we just take this and group them together. Then the other 10 10 10 will group them together. So I have 9 times 2 times, you can just choose your calculator to solve directly if you want that. 1.6 times minus 1.6 times 10 10 10. So I take 1. So by the power of indices, 9. Our multiplication in indices is what? Plus. So it's plus minus 19 plus minus 19. This guy's already in 10 10 cents, so I just take 1 minus 19, sorry, minus 13 plus bracket minus 13. So when you calculate this, as you have 9 times 2 times 1.6 times 1.6. That gave us 46.08. 46.08. Plus times minus is what? Minus times 10. 9 plus times minus minus 19 plus times minus minus 19. So you're owing minus 19 minus 19. That is minus 38. So minus 38. You not so minus 38 and you have 9. So 9 minus 38. 38. You have what? Yeah, you have minus 29. All over. Minus 13 minus 13 is what? Minus 26. So 10, 10, 10. I take 1 minus 46.08 times 10 minus 28. By law of indices, division is minus. So minus 1. So the minus bracket minus 26. So 46.08 minus 28 minus, that is 10 minus 28 plus, plus minus of minus is plus 26. So when you pay off 26, you pay minus 46.08 times 10 is power what? Minus 2 Newton. Or you can just adjust this point forward. When you move this point forward, it give you minus 4.608 times. It reduces your power to minus 1. Okay,